Kia ora. So we're going to look at an excellence version of finding a scale factor for a parabola. So this one is, what I've done here is I've got some moving points. But the thing that I want you to notice is that the marbles are dropping from A, B, and the top of the tube is going to be happening at C, D. So let's just draw that out. So I've got this point up here, which is A, B, and then the marbles need to go along some sort of path until they get to the top of the tube, and this is defined by CD. Now, the thing is, we now have two sets of unknowns rather than knowns that we can substitute in. But the thing is, with algebra, we can still build equations with unknowns, because these unknowns are set points. So what we're going to do is we're going to try and make this parabola, and the parabola is going to follow the same rules. It's still going to be y equals x, y equals, and I can't use a because a is already taken, k x minus h squared plus v. Right? So we're going to have to find a parabola that matches this, but it's going to use this as our coordinate. Well, actually, I don't want to use that as a coordinate. I want to make a new coordinate down here, right? And I want to drop it down a little bit. So I actually want to, because A is the horizontal movement and B is the vertical movement, I'm actually going to drop it a little bit. So I'm going to go A and I'm going to go B minus, let's go 1, just so it's a nice number. Right, so this is going to be my coordinate, right? And this over here, I'm going to use that as my vertex. So the same rules apply as before. If this is my vertex, C is my horizontal shift, H, and D is my vertical shift, V. So I can already write out my parabola as y equals k x minus, and then I've got my horizontal shift, which is C, squared plus my vertical shift, which is now D. Right? So actually, all of the information I need to know about C and D is already covered. So now, all I'm doing is dealing with this coordinate that I want it to pass through. And so this is where you're going to find some sort of heavy algebra. I mean, once you've seen it done, it's not super complicated, to be quite honest. So all we're going to do is we're just going to substitute this in. So substitute A and B minus 1, and I want it to drop to B minus 1 because I need the marbles to be able to drop. So they're always going to, the parabola that we draw is always going to be 1 unit below B, so it gives them some sort of breathing room. Okay, so let's substitute that in. So A is remember that's my X, and that is my Y. So let's just substitute it. So it's going to be B minus 1 equals, and K is our unknown that we're solving for. X I can now substitute in as A minus C squared plus D. So actually all we're doing is we're just going to rearrange this so that K is by itself, or I like to say isolated. So I might even do K in black, just so I know what I want at the end of it. So I'm pretty much just moving this stuff all to the left hand side, and then I will have a value for K, and it's going to be messy and it's going to be filled with a lot of letters. So we're following Sam Deb. So is there any subtraction? Yes, but it's inside brackets. Is there any addition? Yes. Let's do the opposite of addition. We will minus D on both sides. So it's going to be, I should do that in blue. Given your excellent students, I'm actually not going to be bothered writing out the steps. I'm just going to do them. So it's going to be B minus 1 minus D equals, and then I'm going to do my black K, and then in brackets a minus c all squared. Now, at this stage, I could say, well, there's a bracket and there's an exponent. So I could do the opposite of an exponent. I could get a square root over this. But actually, if I'm square rooting this, I need to square root everything. So I would square root everything here, and I would square root this, but I would also have to square root the k, and that overcomplicates the k, so that's not actually the right step. Another thing we can do though, and it's sort of a hack, is we could just divide by this whole thing. So bracket a minus c bracket squared, and I can just divide by everything there, and it's sort of like a hack because it makes this algebra actually really easy, and probably a little bit easy for an excellence, to be honest. So we will be marking harshly. So a minus c squared is equal to, dang it, I want that in red, is equal to k. Now, I have my scale factor, so let's go back and substitute that in what we know so far and see if it works. So everything's moving chaotically, but that's all good. Y equals, right, and now I've got to substitute that k value in, so I'm going to start off with a fraction. On the top I had b minus 1 minus d. On the bottom, I had bracket a minus c all squared. Notice it's moving now. Oh, we're getting something. But now we need to make it that parabola. So it's going to be x minus, and what was my horizontal shift? It was c. And then I need to square that. And then what was my vertical shift? It was plus d. Now, notice that these variable points now always get a parabola that works for it. But it requires this sort of complicated looking formula. But actually, this formula can't be simplified any more than it is. Right? So that's what it is. But what we're also going to have to do is we're going to have to find out what do we want our domain for this to be. So actually, I want my domain. Well, so we know that the red point is the leftmost. So the red point has a as its x value. So let's start with that. We're going to go a. I'm actually going to go minus 1. So that has a little bit of room to breathe. Less than x, less than, and now the top center of my tube, actually that goes to c. So if I put c in here, it's going to lead it to there. I actually want it to go give it a little bit more room to breathe again. So I'm actually going to minus 0.5. And I'll make this minus 0.5 as well. And I think that makes a parabola that would always catch the marbles and let them roll into the tube, right? And so let's just review. So what we did was we substituted in our vertex that we decided was CD. We then substituted in for x and y so that we could solve and find a scale factor. And all the maths necessary for doing that is laid out just here. That's not all you have to do for the excellence component. There are actually a few other things that are required for excellence, and I'm just going to pull them. No, I can't pull them onto the screen actually. What you need to do is you also need to list assumptions made for the final equations, right? So I'm going to have to list some assumptions for this as well. I need to make assumptions like whether or not A, B, C, and D, when they cross over, right? So I need to think about maybe these, if this crosses over to the right or this crosses over to the left, is this going to ruin what my parabola does? So you're going to have to discuss those sort of things. Anyway, that is the basics of one of the excellence skills, which is finding a scale factor. Finding a period or amplitude is actually very similar, but finding scale factor is the easiest option.